We recently talked about how to set up proportions with triangles that are similar given that they have a similarity statement. So we are going to run into some situations where we don't have a similarity statement, but there are going to be other ways for me to tell how the sides match up. And in this case, what we're going to talk about today is how to prove triangles are similar. We proved that triangles were congruent last semester, but how to prove that they're similar. And the reason that we want to prove that they're similar is so that I know how to set up problems. And we're going to do that in another lesson. But we have three similarity postulates and theorems. The first one is called the angle-angle postulate. The angle-angle postulate, if you remember, the angle-angle postulate did not prove that triangles were congruent. The reason why is I could take a triangle that's equiangular, all three angles are 60, and I can take a teeny tiny one, and I can take a bigger one. They all have 60-degree angles that add up to 180 degrees, but they're not obviously the same size. So what we know, though, is that they have to be similar. And so if I have two angles of one triangle that are congruent to two angles of another triangle, then those two triangles have to be similar. This is going to be the most important one that we use when we're actually trying to set up to solve problems. Another way that we can tell, and we've already kind of started doing this, but another way that we can tell that triangles are similar is if all of their sides have the same ratio. Here's what this means. When you look at these two triangles, you notice that AC is the shortest side and DF is the shortest side of its triangle. So I'm going to compare AC to DF. Well, AC to DF would be 2. And so then I'm going to compare, you might pull it over all onto one triangle. Then I'm going to compare medium to medium. Well, medium is BC, which is 14, and EF, which is 7. So then I've got 14 over 7. That's also 2. So far, so good. And then I need longest side with longest side. So that's going to be 20 over 10, which is also 2, or 20 over 10. You can look at it there. If all of those sides are the same ratio, if I have three pairs of sides that have the same ratio, 1, 2, 3, they're all the same, then I can say that my triangles are similar by side, side, side. If any one of those numbers is different, then do a quick double check. But if any one of them is different, then the answer is no, they're not similar. They all have to be exactly the same. Then we had a side angle side theorem for proving congruence. We have that same idea. You have your two sides, you have your angle in the middle. But the difference is before, your sides had to be congruent and your angle had to be congruent in order to prove the triangles were the same size. Now we're trying to prove they're similar. So we're going to test our short side 18 with our short side 6. Well, that's equal to 3. And then we're going to test our long side 30 with our long side 10. That's also 3. And then this is 53 degrees. That's 53 degrees. So since those are the same, since the angle in the middle is the same, so I have a congruent included angle, and my sides have the same proportion, which is 3. One is 3 times bigger than the other. Then these two triangles would be similar by side, angle, side. And so when we look at these, it says is either LMN or RST similar to ABC. So here's what we want to do. You take all the sides of ABC and you match them up. Well, notice that AC and AB are both 10, and ML and MN are both 8. And so we're going to have to match those two pieces up. Your like sides have to match, and then your leftover side is over 12. Well, 8 over 10 is not the same as 6 over 12, okay? 8 over 10, if you look at 8 over 10 and you look at 6 over 12, they're not the same. And so then that one doesn't work. Then if I compare RST, compare your two sides, I have 5 and 5 and 10 and 10, so those have to be my matching pieces. And then 6 and 12. Another hint that you could see is that you can't match up on LMN, you can't match up 12, which is the longest side, with 6, which is the shortest side. So that's one reason why we know that won't work. But then the other two sides had to be the same. So you had to match those up with the 10s. But if you look at this, 5 over 10 is 1/2, 5 over 10 is 1/2, and 6 over 12 is 1/2. So that means that RST is the one that is similar to ABC. Number 2 says to determine if the triangles are similar, and if so, write the similarity statement and find the scale factor from triangle A to triangle B. So I notice that I have my congruent angle. That angle is in between the two sides. Then I'm going to compare my short with my short. So my 3 gets compared with my 12, and my 4 gets compared with my 16. 16 over 4 is 4, and 12 over 3 is 4. So they have the same ratio. They have the same angle. So yes, they're similar by side, angle, side. Then we want our similarity statement, and we want to go from A to B. So I did 16 over 4. Well, that's 4 over 1. So my scale factor is either 4 over 1 or 1 over 4. If you remember, if you multiply by a number bigger than 1, it gets bigger. If you multiply it by a number smaller than 1 but bigger than 0, then it gets smaller. So I got bigger. I went from A to B, and so I got bigger, and so my scale factor then would be 4 over 1, or 4, because B is 4 times bigger than A. Now, let's look at how these match up, because sometimes not everything is as easily marked. So let's check. Are they similar? And if so, tell me why. So this looks like it's going to be a side, 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 but we always need to check and make sure that the answer is a yes first. So we match our short with our short. So 9 is the shortest, and I'm going to match it up with 6. I just like to organize it all like this on my triangle. 12 over 8 and 13.5 over 8.8. Well, when you reduce these fractions, you get that 9 over 6 is 3 over 2. And you get that 12 over 8 is 3 over 2. And 13.5 divided by 8.8 is 135 over 88. And you can change those to decimals if you want. It can be 1.5. This is 1.5. This is 1.5. And this is 1.53, which is close, but it is not the same. And so, no, these triangles are not similar. Now, if you look at number 4, I have this pair of right angles, but remember I need 2 pair. 2 angles on one triangle equal to 2 angles on the other triangle. So you look at the triangle and you go, ask yourself if there's anything else you already know. Well, if you remember, we learned about vertical angles in the last semester, and so those 2 angles are congruent. So now I have 2 angles of my little triangle matching up with 2 angles of my big triangle, which means that yes, these are similar, and they are similar by AA. 5, if you look at 5, so be careful with this one. So sometimes you might need to draw these overlapping triangles as 2 separate triangles. Well, what you'll notice is you have 1 pair. Here's 2 angles, and you need 2 more that match. Well, what we actually have, you can't see it because they kind of overlap, is that this angle right here at the corner belongs to the little triangle, it belongs to this triangle, and it belongs to this triangle. And since it belongs to both, it is equal to itself. That's called the reflexive property. And so we have these 2 angles are equal to each other. We have this angle is equal to itself. So we would say, yes, these 2 triangles are similar by the AA theorem of similarity. Okay, number 6. You may double check your notes. You may have a 9 there. You should have a 12. There's a reason for that. This looks like it potentially could be side angle side, so I'm going to look at it real quick. There's my side, and there's my angle in the middle. There's my side, and there's my angle in the middle. But wait, I don't have that angle in the middle, so there's an issue. So let's see if we can find it. I have 70 and 30 is 100, and so that would be 80. And then if you find your other triangle, 80 and 30 is 110. Subtract that from 180, and we get this angle is 70. So here's what happened. If you have 9 there, we may have fixed it by now, but if we didn't, we knew that there was a mistake because these have to be similar by AA because you have 2 angles that match with 2 angles. Now, it could also be, if you check it, that's why we had to fix it, because 8 over 12 and 10 over 15 have to be the same. So it can also be side angle side. You can't be similar by AA and then not similar by side angle side. So we had to fix the problem. Now in 7, notice that you have parallel lines. So I've got these parallel lines, and so those come in handy. Again, you might need to split this into 2 separate triangles, your little one and your big one that gets overlapped. Well, what I know is that if lines are parallel, corresponding angles are congruent. And so I have both of those situations on that side, or this angle is congruent to that one. This angle is congruent to that one if you move it over into its 2 separate triangles. You might have also noticed this angle up here, because we just talked about it, being the reflexive property. So now that angle is equal to itself. All you need is 2, and since I do have 2, I can say that these are similar by the AA similarity. Okay, and then we have our last one we want to check. Looks to me like it could be side, side, side. Let's do a quick double check. We match our short with our short, so 15 is the shortest and 3 is the shortest. We do 21, which is the medium side, and 4.2, and 17 and 3.4. By just glancing at it, it doesn't look like they match up. But if I do the math and check it, 15 over 3 is 5, 21 over 4.2 is 5, and 17 divided by 3.4 is 5. And since all of those are exactly the same, I can say, yes, these 2 triangles are similar by the side, side, side similarity theorem. Okay, and so we're going to find out more about when we need to use this, but there are 3 theorems and postulates that prove that triangles are similar. When you have 2 angles congruent to 2 angles, when you have 3 side pairs that have the same ratio, and when you have 2 side pairs with the included angle being congruent. When those 2 side pairs are proportional, then those triangles can be similar by side angles.